Welcome to my problem solving class of Advanced Microeconomics. Today we are going to solve problem set 2, utility and demand, and this is chapter number 2. Let's start our solution. Consider consumer in two goods world. To show that a given good must be inferior using Slutsky equation, and in B we have to show that inferior good doesn't need to be given good. Again, we can use this Slutsky equation to help our discussion. So given good is given good must be inferior good, but inferior good doesn't necessarily be given good. Let's go for the solution. Okay, so the valuation demand of a given good decreases when price increases. This is the definition of given good. So d del xi del pi is positive. Price and demand move in the same direction. Alternatively, valuation demand of a given good has a positive slope. That means normally our demand for any good, normal good, is downward sloping, but for given good it is upward sloping. From the definition of Slutsky equation, we know that substitution effect must be non-positive. Okay, so SII, our substitution effect, in the last exercise we have seen that substitution effect is SII is negative. So here is the substitution effect with total effect and income effect. So we can say that income effect must be negative. Income effect must be negative. Why? Because this is negative. In order for this to be negative, it must be negative because total effect is positive. Those goods for which income effect is negative, that is valuation demand decreases as income increases. So if income effect is negative, that means the good must be inferior good. So when there is a negative relationship between income and good, valuation demand for good and income, then it is inferior good. We can depict this by a graph, figure 2.6. A given good must be inferior. Substitution effect entails an increase in the amount of good X consumed after price decreases, as captured by rightward movement from A to B. This is the direction of movement for substitution effect, and it is obvious that this movement is, although rightward movement, it is the negative in case of consumption of goods. And why total effect is positive? That means change in world Russian demand with respect to change in price is positive. Which is also in case of given good, is that income effect not only moves in the opposite direction of the substitution effect. So you see in the graph, substitution effect move to the right, income effect move to the left. Okay, the process of substitution effect and income effect. The substitution effect on the same utility function u2, okay, and income effect occurs when there is a, the original budget pivoted to the right because of price decrease, and for the compensation of this pivoting to the right, there is a shift of the new budget line to the left as a consequence of substitution. So to remain on this same utility function, consumer move from A to B, and this is called substitution effect. But originally, for income effect, the movement is from B to C because the pivoting of the budget line. Okay, so that's why this movement is from A to B and then C. So the income effect not only moves in the opposite direction of the substitution effect, reflected by the leftward movement from B to C in the figure, but the negative income effect exceeds the substitution effect in absolute value. So we know that the movement to the right is negative for substitution effect, but movement to the left is negative for income effect. Okay, and this movement is more in absolute value than the substitution effect. So this is substitution effect and this is income effect. So the absolute distance is more, although both are negative. The absolute movement for both is not the same. The income effect is more. That exceeds the substitution effect in absolute value. So we can say that TE is greater than 0, although SE is negative and IE is negative. So this negative is more than that. That's why TE becomes negative. I mean TE becomes positive. Why? Because SE itself negative minus IE. So this minus and this minus becomes positive, and there is a negative sign here. So this the value of this, absolute value of this, is bigger than that. So that's why TE is positive. And if TE is positive, what does it mean? Total effect is positive. Change in demand with respect to price, total effect. So total effect is positive. Change in X with respect to change in price is positive, means demand increase, price increase in the same direction. That means given good. And this given good is because income effect is negative. And why income effect is negative? Because it is inferior good. So this proves that given good must be inferior. So in order for a given good inferior, the income effect is negative, and that negative amount, that negativity is more in absolute value than the negativity of a substitution effect. That's why inferior good is must for given good. I mean given good must be inferior. Now part B, graphically show that inferior good doesn't need to be given good by using a Slutsky equation. So given good must be inferior good, but inferior good doesn't necessarily be a given good. So let's show it by providing an example of a good which for which the total effect is negative. So if total effect is negative, then the good is not a given good. So if the good is not a given good, but the income effect is negative, that means inferior good, then we just need to use Slutsky equation, where SII, that means substitution effect, is negative by definition. Simply this 3 lines says that we are taking a non-given good, but non-given good, that means this inequality, and inferior good, that means this inequality. Income effect is negative, and use this Slutsky equation. So negative substitution effect, obviously, negative total effect for non-given good, and negative income effect for inferior good, non-given inferior, and this is obviously positive because it is demand. Alternatively, we can say that total effect negative, substitution effect negative, income effect negative. and this is possible as long as income effect, that means this, despite being negative, that means inferior good, does not exceed in absolute value substitution effect. If the absolute value of this is greater than absolute value of this, then income effect total effect becomes negative. Why? Because we see that SE is negative minus IE, so it becomes positive. So if this is less than this in absolute value, then TE must be negative. By equation we can see. Let's see in the figure 2.7. So we see that movement from A to B is a substitution effect, which is negative. So moving towards, for substitution effect, moving to the right is negative. For income effect, moving to the left is negative, and for total effect, moving to the right is negative. Okay, so here you see that the absolute length of substitution effect is greater than the absolute length of the total income effect. That's why total effect becomes negative, because it is moving to the right. Let's see what is written here. Figure 2.7 depicts a decrease in good X, reflecting that while being inferior good, the income effect is negative. That means inferior good means income effect is negative. It is not a given good, because income effect does not fully offset the substitution effect. So income effect is this length, and substitution effect is this length, income effect is this length, and remaining portion doesn't covered by the remaining portion is not covered by income effect. So this portion being moving to the right, this portion is total effect, which is negative, and total effect negative means del X divided by del P is negative, so it is not given. Okay, so here we see that it is movement from here to there, and then there to C. So it is not, the good is not given, but it is inferior. Okay, so the general idea is, if C lies behind A, then both the good is both given and inferior. If it is in C is in between A and B, it is not given but inferior. If C is lying ahead of B here at some point, so it is neither inferior nor given. So the position of C is very important for being given or inferior. So when C lies behind A, some point here, it is given plus inferior, G plus I. If C lies between A and B, it is non-given but inferior. If C lies here to the right of B, it is neither given not inferior. This is the general idea of given good and inferior good. Rightward movement from A to B in the horizontal axis does not completely offset by the leftward movement from B to C. Thus, the total effect movement from A to C is still negative, indicating that decrease in price of good X still yields overall increase in its demand. This is an important statement. So this ends our 2.5. Let's move to the 2.6. 2.6 says about the relationship between WARP and CLD. Here CLD means compensated law of demand. Consider the following figure. This is the figure 2.8, illustrating a change in the decrease in price of good 1. That means producing a outward pivoting effect on the consumer's budget line from red line to the uncompensated demand to the right blue. The price of good 2 remains constant. That's why a pivoting effect. So this means that consumer receives a wealth compensation, changing wealth level from W to W prime. So wealth changes is there from W to W prime. That guarantees he can still afford the consumption bundle XPW. So this is consumption bundle. So movement from here to there, price changes because of price decrease. So bundle is still affordable because it is below the blue line and on the red line. Red line means original uncompensated budget line, and blue line is compensation in wealth, after compensation in wealth, I mean because of compensation in the wealth. And this type of wealth compensation is called Slutsky wealth compensation. Assuming that Walrasian demand satisfies weak axiom of revealed preference WARP, answer the following question. The question says that new bundles cannot lie on this segment here. This is a segment of the new bundle budget line A to the left of bundle XPW, but it must lie on the B part of the new budget line to the right of bundle. This is one question A. Question B, we have to infer a conclusion about this about the result in part A. And slope of the action demand function. So A says bundle X P prime W prime cannot lie on A, but it must lie on the on segment B, which is to the right of the bundle. In order to check whether bundle X P prime W prime being segment of A and B compatible with WARP. Let us assume that it lies in each segment A. So in order to prove that bundle X P prime W prime cannot lie on segment A, we apply WARP and note that both bundle X PW and X P prime W prime are affordable under the initial price and wealth. Initial price and wealth, that means uncompensated budget line. Graphically they are both lie on or below the budget line. So these any points in this area the bundle X prime, if this is a point and this point is X P prime W prime and this point is X P W, both are lying below on or below the two budget lines. In the second step of WARP, we see that this is affordable under this line. Okay, so XP is affordable, this bundle is affordable under this line, dashed line, that is it lies on the dashed budget line, which constitute the violation of WARP. So if in our WARP case, if these are two two budget line or two budget set, so if one point is here and other point is there, that means ARP violated. If the point is here, which is under the red line, and this point is on both red line and dashed line, then we can say that this violates WARP. That means any point on any of this area, that means on segment A. So X P prime W prime cannot lie on the on segment A. What about segment B? In segment B, X P prime W prime can lie on segment B. Why? Because we see that suppose X P prime W prime lies here, but this is not affordable because it is lying above the red line. Considering XPW lies on the budget line BPW, XP prime W prime lies above BPW. So that's why hence the premise of WARP doesn't hold, and as a consequence WARP is not violated if x p prime w prime lies on the segment B. Okay. Now 2.6 part B. It says that what conclusion can we infer from the result in part A about the slope of the Wallersian demand function and the slope of the Hicksian demand function. From the previous result, we conclude that x p prime w prime contains more of good one because it lies in segment in this segment. So more of good one. So this is the x1 is the horizontal axis. So if anything lies, this is the point. So if this is the point for x p w, and this is the point for x p prime w prime. So obviously the good one is more of good one. So a decrease in the price of good one. So we know that the pivoting result was for a decrease in price. So a decrease in price of good one, P1 decrease, leads an increase in the consumption of good X1. This is compensated law of demand, and it implies that Hicksian demand curve must be negatively sloped. So because of this relationship, Hicksian demand is negatively sloped. So this is the inference about the Hicksian demand. What about the Wallersian demand? We cannot guarantee that uncompensated law of demand is satisfied. Why? We know that the uncompensated law of demand produce Wallersian demand. So we cannot conclude that Wallersian demand curve in which wealth effect are left uncompensated. So we cannot conclude that it is Wallersian demand curve is negatively sloped. Why? Because it can be positively sloped or negatively sloped depending on whether the good is given or not. That is the reason why we cannot say that Wallersian demand curve is negatively sloped or positively sloped. But this is not necessarily true for Hicksian demand. Hicksian demand is always negative because of the substitution effect is always negative. And because the wealth is compensated in the Hicksian demand curve. But in Wallersian demand, wealth is not compensated. It could be given good when demand curve is positively sloped, or it could be negative sloped when the good is normal good. So this ends our problem number 2.6. Let's move to problem number 2.7, and it is about slot schematrix. Now we consider three goods given by the Wallersian demand curve. X1 is P2 upon P3. That means X1 is the ratio of P2 and P3. X2 is the ratio of minus negative P1 upon P3. X2 is the negative ratio of P1 and P3, and X3 is the ratio of W 2 P3. So these are the Walrasian demand for 3 goods. L equals 3. Show that Walrasian demand is homogeneous of degree 0 in prices and wealth. Show that X PW, that means Walrasian demand satisfies Walras law, and show that X PW violates weak axiom of revealed preference WARP. And also show that also find Slutsky matrix SPW. Solution. In order to show the homogeneity, we need to increase prices and wealth by a common factor lambda, and to above equations, 3 equations. So common factor lambda, x1 produces the same demand, x2 also produces the same demand, and x3 also produces the same demand. So we can say that increasing both prices and wealth by the same factor lambda doesn't change this consumer's demand. So if we double prices of all goods and income, the individual's demand is unaffected. So the demand curves are homogeneous of degree 0. Next, show that X satisfies Walras law. Walras law states that strictly positive price vector and positive wealth P dot X equals W. Alternatively, sum of, that was in dot matrix, and this is in summation. Sum of price quantity among the individual goods equal to price times quantity, sum of price times quantity equals W. So this is the equation for Walras law. In our three goods context, we can formulate the equations for Walras law. So if we insert the values of x1, x2 and x3, we find that this is W, and further rearranging them. So when you say that this one equals that, we know that Walras law is satisfied, confirming that in the individual spends all his income on goods 1, 2 and 3. So this is the Walras law. What about C? Show that XPW violates the weak axiom of revealed preference, WARP. So in order to prove that, we use counter example. Here is our Walrasian demands for 3 goods. So let's take this as counter example. W equal to 1 and P are all 1 1 1. That means P1 equals 1, P2 equals 1 and P3 equals 1. So putting all P's here, we get X P W. So 1 minus 1 and 1. So let's take this as an example, and let's take W prime equal to 2, P prime equal to 1 1 2. Which yields similarly, which yields demand half, because of the P2 and P3 are 1 and 2, so half. P1 equal to 1 and P3 equal to 2, so minus 1, sorry, P1 1, P3 2, minus half, yes, and W1 and P3, W2 and P3 2, that means 1. So this is our examples. So in order for WRP to be satisfied, if for any pair of two prices and wealth, this is our definition for WRP. That means the new bundle with price is affordable, old price is affordable. Old bundle with new price must not be affordable. That means not this. If this is true, then it must not be affordable. So this sign is unaffordable sign. So in our example, the bundle that consumer selects at final price wealth pair is affordable under initial price wealth. How? Because here we see that this one, P initial price and new bundle is, we know that P equals 111, this times this, because dot matrix is row column column row. So if we multiply this, so 1 times half is half, plus 1 times minus half is minus half, plus 1 times 1 is 1. So this is half and half cancel out, so it becomes 1, and we know that 1 equals 1. 1 is less than or equal to 1, which is true, affordable. Now we see that the second part of the definition. Now this is, if this is that, then we say that WRP is not valid. That means WRP holds. So if we see that our P prime is 1 1 2, as we have seen in the last slide, and XPW is 1 minus 1 1. So if we multiply this by 1 times 1 is 1, 1 times minus 1 is 1, 1 times 2 is 2 times 1 is, sorry, it should be 2. 2 times 1 is 2, so 1 cancel out, it is 2. And since W prime is 2, bundle X is exactly affordable, that means our case is not unaffordable, it is equal, I mean P prime dot X P W is equal to W, it is not strictly greater. If less than or equal to W, then it is affordable. So affordable in the final price and wealth, implying that the conclusion of WRP is not satisfied, therefore WRP is violated. Now finally, Slutsky matrix. Let us first recall that Slutsky matrix is this one, a complex matrix is called Slutsky matrix. So each one implies the left hand side of Slutsky equation. Okay, and we know that Slutsky equation, in Slutsky equation SE equals TE plus IE. So this SE is SII, and this contains total effect plus substitution effect, and all SII constitute this matrix. Okay, so when I equals I, so it becomes diagonal matrix and diagonal line, and when I equals J, and when I not equals J, these are off diagonal. So every component in SIK, or you can say it Sij, is defined as this matrix. This is Slutsky equation, and this is all element depending on the value of I and K. We are setting all element in this matrix, and because our L equals 3, so we are getting 3 by 3 matrix. Okay, all right. So this is the remainder of all Walrasian demand. From this demand, we should get SIK, all SIK. So let's try. S11. What is S11? S11 is, this one means for good X1, and this one means for price P1. So first subscript is for good and second subscript is for price. So, and for the first part of this Slutsky equation, and the second part of this Slutsky equation is for this is obviously good X, and this is for this doesn't I mean this is not necessary for this because W is W. Okay, so we have seen that this is 0 plus 0. Why 0? Because in this equation there is no P1, so here 0. And the second equation XW, there is no W, so 0. That's why it is 0. Next for 1 2, so good x1, price price p2. So first p2 is there, so 1 by p3. Second, w, there is no w, so 0. Okay, so it is 1 by p3. All right. One 3 means good x1, price 3. So it should be, because p3 is the denominator, so p2 divided by p3 square with minus n. Why minus n? Because it is the denominator. So if it is numerator, then it is p to the power minus 3, so p3 minus 2, so 1 by minus p3 square, and p2 remains as a coefficient. So here this one plus, there is no w here, so we don't see anything here, so it is 0. So this is the case. Similarly for 2 1, good 2, price 1, so 1 by 1 upon minus p3, 0, because there is no 0, there is no p, I mean p2 here, so 0, 1 by p3, minus 1 by p3. Similarly we can get s22, similarly we can get s23, s31, s32, s33. Okay, so arranging all values, from the last slide we have got s11, s12, s13, s21, s22. So these all constitute the Slutsky matrix. So this is our final matrix. This ends solution 2.7. What about solution 2.8? And 2.8 will be our last problem in problem set 2. Compensating an equivalent variation. An individual consumes only goods 1 and 2, and his indirect utility function V P1 P2 W is given by the following expression. We have to find this individual's valuation demand for good 1 and for good 2, where P denotes price vector P1 P2, and then find the ratio. We have to find this ratio. B is similar to A, but it is on individual's Hicksian demand, and find the similar ratio, and in both cases explain the intuition behind behind the result. Question 2.8c says, using valuation and Hicksian demands from part A and B, find Slutsky equation for goods 1 and 2, and explain your result and connect it with your intuition in part A and B. So question C is connected to question A and B. Now final question is, now assume that initial price of good 1 is doubled and price 2 is cut in half. Wealth is constant. So if we denote P0 as initial price and P1 as the final price, we have that P11 is 2P10, that means doubled, and P12 is half P20, that is cut in half. So question D, 2.8D, has two parts. One is find compensating variation CV and explain the intuition behind CV's measures, and find the equivalent variation due to price change and explain the intuition behind these measures. Now guess the solution. Now move to the solution. In order to find world Russian demand, we use Roy's identity, and which is the equation for world Russian demand, which is negative of derivative of indirect utility function with respect to price, derivative of indirect utility with respect to W. This is Roy's identity. So in particular for good 1, we find that x1 PW is this ratio, okay, and finally we have got x1 equal to W divided by P1 plus alpha P2. Similarly for good 2, we get the alpha times W divided by P1 alpha P2, and hence the desired ratio is alpha. So that was our final result for part A. So what is the intuition behind this? The intuition behind this, the demand for good 2 is constant proportion of alpha of the demand for good 1. This constant proportion holds for any wealth level and any price vector. Since goods are consumed in constant proportion, these two goods are perfect complements. That means Leontief indifference curve. So because of the constant proportion of one good by another, constant proportion holds for any wealth level and price level. So goods are consumed in constant proportion, so it is a perfect complement. The two goods are perfectly complementary, so we can say that our IC is Leontief IC, like this, L-shaped. Now question B, 2.8b, says the similar thing about question A, which is finding Hessian demand and the ratio between the two goods. So for Hessian demand, we need to use Shepard's lemma, and the Shepard lemma, in order to find the expenditure function, we first use the following properties. So W is equal to expenditure function, that means value function for expenditure, and minimum value function means expenditure function, and maximum value function, that means indirect utility function, should be equal to U0, and W should be equivalent, not equal to, equivalent to EP U0. So this is the relationship between indirect utility function and expenditure function through wealth and utility. Using them in the expression of indirect utility function, we are given this. We have simplified this as this, because this is equal to that, and this remains the same. Now we can use the Shepard lemma. What is the Shepard lemma? Shepard lemma says that the Hicksian demand is equal to the first derivative of expenditure function with respect to price. So from the previous slide, we see that EPU0 is equal to U0 P1 alpha P2, so it is U0, and for this, why U0? Because here only this is P0, there is no P0 here, so U0. By this we can find the second Hicksian demand, and this is that, and the ratio is now second Hicksian demand upon first Hicksian demand is equal to alpha. Same result what we have got from Walrasian demand. This result confirms the previous result, and the intuition is the same. Now question 2.8c. Using these two demands from part A and B, find Slutsky equation for goods 1 and 2. So here is the Slutsky equation. Substitution effect equals total effect minus income effect. From the Hicksian demand found in part B, first Hicksian demand is U0 and second Hicksian demand is alpha U0. So we can so we have, this is not actually SE, this is a SE, this is TE and this is I. Okay, so this is del HI P U0 del PI equal to del HI P U0 del PJ equal to 0. Why? Okay, because of this, this is utility constant, so derivative of this with respect to P is equal to 0. Here derivative of this with respect to Pj, because P is P1 P2 or Pi Pj, and this is U0 which is constant, that's why 0 here. So this one with respect to, if we say that if we combine both, okay, so we can convert Slutsky equation into this, so this becomes 0, so only remains this one and that one. So here this one and that one, This result come as no surprise. Why it is not a surprise? Because these goods are perfect complements, implying that total effect contains no substitution effect. So our substitution effect is equal to 0. Total effect is income effect. That's why because the two goods are perfect complements, no substitution is there. Now 2.8D. 2.8D has two questions. One is for CV and other is for EV, equivalent variation and compensating variation. First we take the compensating variation. Compensating variation is the monetary amount that after price change must be given to the individual in order to maintain him the same indifference. Note this down, same indifference curve as he was before the price change. That is called compensating variation. That means CV is expenditure function with original utility with price change minus after price minus original utility, expenditure function with original utility before price change and price before. And this equation actually comes from the original equation. Original equation was the difference between E PU0 P1U0 minus P1U1, and we know that this one equal to W, and then this remains the same, so this W is also equal to P0U0. So P1U1 equals W equals P0U0 because of compensation in wealth. Wealth compensation is done by this equality. This equals that equals that. Okay. Graphically we can try for that. We have seen that there is a price increase. Price for good one increase. So if we have this as original budget, price increase means a leftward pivoting. Okay, so and there is a compensation, parallel movement should be there for compensation. So this could be the origin, original utility, and this could be the new utility U1, So this budget line is E P1 W1. This budget line is E P0 U0, and the dashed budget line is E, because these are parallels of P prime U0, P1 U0, because U0 is so the CV is the difference, this difference between first difference between EP1 U0 EP1 U0 minus this dashed line minus the new budget line EP1 U1. Okay, so this parallel, and then this dashed line and the original budget line cross each other. That's why there is a compensation. So the W remains the same between EP1 U1 and versus EP0 U0, and together we get this equation. And now we apply the price, value of price from part B. We know that this one is EP U0 is U0 P1 alpha P2. We just put them down. So EP1 means EP11 plus alpha P21 minus EP0 U0 means alpha U0 P10 plus alpha P20. So here both are 0, superscript 0 superscript 1 superscript for price, and 0 is 0. U0 is 0 and 1 for price. So this can be converted into this. Why? Because we know that P1 is doubled and P2 is half. P1 remains the same here. Okay, and now we simplify this into that equation. So this is the result for I 2.8 DI. Now what about the equivalent variation due to the price change? First, the definition of equivalent variation, EV, which is the monetary amount that before the price change must be given to the individual in order to make him reach the same indifference curve he would reach after the price change. That means consumer will remain on U1. Before, consumer would have remained in U0. Now consumer would have remained in U1. So the difference between the expenditure function defining EV is this. So EP1 U1 minus EP0 U1, that means the U1 remains the same here for EV, and for CV U0 remains the same. and again it is coming from the original derivation. And how original derivation is there? In case of equivalent variation, we can say that again we derive the original, and because of the good one price increase here, then it is pivoting. We need to have a parallel shift of the original curve, because we want to move to the after price movement utility curve. So dashed line should be this. Sorry, this should be dashed line. Okay, so our new u1 here and u0 is there. Okay, all right. So again we can say that this is e p0 u0. This is e p1 u1, and that is p e p, because it is parallel to that, so p0 u1, and EV is actually the difference between this parallel budget line. So actually difference between E P0, that means this one U0, minus E P0 U1, this one, so this minus that. And because our wealth remains the same for EP0 U0 and EP1 U1, so this is W and that remains the same. So if we can simplify, then we get this equation. But remember, our in our case, in our example, both price decreases, but in this graph only P, for the sake of understanding, we raise only P1 and keep P2 constant. In our example, price 1 increases, price 2 decreases. So from the result of part B, we got EP U0 equals U0 P1 plus alpha P2. We insert this into that. Okay, both cases, and apply the condition for price change. P1 equal to double P1 0, P2 equal to half P1 P2 0. We get this, and again we simplify this and find this result. This ends our problem 2.8 as well as problem set 2 of chapter 2. Thanks for watching. References. Thank you.